All right, section 6.4, we're finishing up proportional reasoning. We had talked about the fact that as we're working with these different proportions that we're setting up, there's more than one way always to set them up, and I should say more than one way to correctly set them up, right? There's actually 4 ways every time to set these problems up, and sometimes there's more, like when we had Kira and Dora, and we were making the comparisons in slightly different ways. So sometimes there's even more options than that. So we've got one here where it's got more than one part to the problem. So at Rattlesnake School, the teacher-student ratio is 1 to 30. If the school has 1,200 students, how many additional teachers must be hired to reduce the ratio to 1 to 25? Okay, so as with any of these problems, we want to think about what are the things that are being compared. So what items are being compared here? Teachers and students. I'm going to put them on the top. If you want to put them on the side, stacked up, numerator and denominator, you can do that too. What else is being compared? Can you tell? We're going to get to the additional teachers, but that's something a little bit different. There's a ratio that they're wanting to achieve, right? They're wanting to achieve a certain kind of a ratio. So there's like the actual number that are happening, and then the ratio that we're hoping to achieve. So maybe it would have made more sense if I had stacked my students and teachers. I don't know. But we're going to do it this way since I've already started because it'll be just fine. So how many actual teachers are there? We don't know, right? We don't know. This is the unknown quantity. Give it a letter name. I don't care. I'm going to call mine X. How many actual students are there? 1,200. We actually know that one. There are 1,200 actual students. What is the ratio of teachers to students? 1 to 30. Okay? So this is like kind of like my scaling factor when I was doing the map, right? So for every 1 teacher, there's 30 students currently. Our goal is something else in the future, but currently that's what this is. And so can we figure out what X is and figure out how many teachers we actually have now? Yes, we can. So we can do this, right? We can cross multiply. We have 30X equals 1,200. Then what would we do? Divide by 30. What is X? 40. This is the 40, I'm going to call them current teachers. Okay, now let's go back to what you had mentioned, Quinlan, about what we are sort of wanting to have happen, right? So we still have the teachers and the students and the ratios, right? All of the setups the same. And this is our actual compared to our ratio. But our 1,200 students, that's the only thing that's going to be the stationary thing here. How many actual teachers do we currently, well, I shouldn't say it that way. How many teachers do we currently want? How many teachers do we want to have? That's better. How many teachers do we hope we have someday? We still don't know, right? We still don't know. I'm going to call it a different letter name, though, because I don't want you to think that this is the same X. It's different. This is the teacher number that we want. And so it's going to be Y. And then what's the teacher-student ratio that we want to have? 1 to 25. Okay? So this is our hope for the future, right? So if you want to say this is our future values that we're looking for over here. Okay? So we have 25Y. If we cross multiply, equals 1,200, then what would we do? Divide by 25. And what does that give us? 48. I'll call them future teachers. There we go. All right, so if I have 40 current teachers, and in the future, I want to have 48 teachers. How many teachers do I need to hire? 8. So we need to hire 8. Does that make sense? Okay. So it's a 2-step process, but it's not terribly complicated. We do have to be careful as we're setting it up that we recognize that there are two different ratios going on, so we're going to have two different proportions going on, and it's not trying to merge it all into one. Okay, these last couple are the connections kind of questions, right, where we're making some sort of an application, observing student work, that sort of thing. So here we have a student, and she's written up a proportion. Mary is working with measurements, and she writes up the following proportion. 12 inches over 1 foot is equal to 5 feet over 60 inches. How would you help her? So generally speaking, when I'm looking at student work, I want to figure out, well, they're kind of giving it away because they say, how would you help her? So they're sort of indicating she's making some mistake. But sometimes they'll ask you to just evaluate it. So we kind of want to figure out what mistake she's making, if she is making one. So can you figure out what mistake she's making?
There's like both inches and feet, and we need the same measurement.
Okay, there's something about the measurements that's going on that's weird here. There's definitely something weird going on. Can you figure out what it is that's going on that's weird? She flipped it. Say that louder, Jamora. Okay, so if we took the right-hand side and we flipped it upside down, right? We flipped it the other way. Would it be okay? Let me try it. So if I wrote 12 inches, 1 foot, will it actually equal 60 inches and 5 feet? Yeah, it will. It'll work if I flip it upside down. Now, generally, I like to tell students something that they did right. Do you see anything, if there is, right? Did she do anything right? Yeah, okay, and it's called ratio. So each of her ratios is actually correct, right? It is correct that 12 inches is the same as 1 foot. Okay, so she has the left-hand ratio right, and she has the right-hand ratio right. Everybody make sense of that? So we should acknowledge the fact that there is something that she did correctly here, because she could have messed up more. That sounds sort of negative, but she could have. There's things she did right, and I think that it's a good place to start when you're recognizing this. And if you choose not to start there, that's fine, but somewhere you need to say it. You need to tell her she did do that right. So I'm going to choose to put that first. So 12 inches equals 1 foot, and 60 inches equals 5 feet. So first, Mary's individual, so I'm going to say Mary's ratios are correct. She has correct ratios. But she has something wrong with her units, like Taryn said. And the thing that's wrong with her units, like Jamora said, is that there's something that's flipped upside down, right? So her units aren't lining up. It's okay that she has like feet and inches up on top of each other, right? But they need to be in the same order. So if she's got inches on the left-hand side over feet, we need to have inches over feet on the right-hand side. Yeah. So her units aren't lining up. Her left-hand side is inches over feet. And her right-hand side, let me say right side, is feet over inches. Okay, so what would you tell her? I don't think, you don't need to number them. I'm numbering them to keep myself organized, but what would you tell her? Well, you probably tell her that she does have the ratios correct, that the sides are flipped, and so what does she need to fix it? What'd you tell us, Jamar? What she needed to fix it?
Not to flip it, just if you're going to have inches on the top on the left and inches on the top on the right.
Okay, so she could change one side or the other, doesn't matter. We'll just go with the right-hand side. She could change the right-hand side, she can flip it upside down so that they match, right? So to fix this, it's not the only option, but she could use we call it the reciprocal, right? It's the flip. On the right instead of, what does she have? 60 inches over 5 feet. Oh, actually, that's not what she has. She has 5 feet over 60 inches. Instead of 5 feet over 60 inches, she could write 60 inches over 5 feet. Right? And you don't need those exact all of the same words, but that's the idea, right? We need to flip one of them upside down. And if we flip one of them upside down, then it's going to look fine. It will be correct. All right, you ready for our last one? All right, Amy's friend told her that the ratio of boys to girls in her classroom was 5 to 6. Amy was surprised that her class would have only 11 students. What would you tell her? Well, first of all, this is very contextual. If this were a special ed class, you might have 11 students and that'd be completely reasonable. Everybody with me on that? I have a student teacher right now, and I'm going to be observing him on Thursdays. So you're going to see, actually, it doesn't interfere with my office hours. I didn't change it, but I'm going to go and observe him on Thursday morning. And I know that he's at Bethel, and he has some classes he has at least one class that's 12 students, because he's working through some of his assessments right now, and I've been reading some of his stuff. So it's possible that there's 11 students, and that's perfectly fine. But assume for the moment that there's not 11 students. Is it still possible for this to be written down and it not be 11 students? It is. So what could be happening here, aside from the fact that it could be 11 students, and that's okay? That's not the point of the question. What can we do, or what can we do to justify or show why this could be okay? Okay, you have 22 students or 33 students. You're exactly right, Jamora. Where did you get 22 and 33 from?
Well, you could just explain to Amy that they simplified it to have smaller numbers.
Perfect. So the ratio is 5 to 6. But if she had, and we'll go with your 22 students for starters, if she had 22 students, where it was 10 boys to 12 girls, 10 to 12 reduces, simplifies, whatever word you want, reduces to 5 to 6 as well. Same for 33 students. We could have, what would it be, 15 boys and 18 girls. Okay, so we're looking for other fractions, right, that would become 5 over 6 when we simplify. So we could multiply the top and the bottom by 2. That gives me the 10 and the 12. Or we could multiply over the 5 over the 6 by 3, which gives me 15 and 18. And this would go on indefinitely. The context probably indicates that we would stop at this point, right? You think about your classrooms. If you have 44 students, you probably are going to quit on day one, aren't you? Probably. Probably not in your best interest to stick around. Yeah, but this would be probably sufficient for the context of what's going on here. But the fraction could continue to have this sort of a nature, and that would make sense, right? All right, does that make sense? Okay, so feel free to tell Mary, was it Mary? No, it's Amy here. Feel free to tell Amy maybe you just got lucky and got 11 kids. But that's not really the point of the particular question we're doing. Make sense? All right.